So off we go again. Anyone have any questions? Yeah. Yeah. Let's go check this out. So the question is about when. Right? So last time we looked at conditionals and we looked at if, and we pointed out that Kotlin doesn't really have support for an equivalent of switch. Instead, it has something called when. Right? So what was your question, Matt? Great question. Let's try it. So, let's look at this one, right? Well, actually, we can test this just using this, right? Yeah. So it looks like, and again, I hope you guys have a copy of this on your. It's kotlin.cs.illinois.edu. That's what I would. You know what? Sorry. Let me just mess with the resolution here. I think this will help. Displays. Kind of want something that's not that. Let's try this. That's better. Okay, good. Now everything's gonna be huge. Okay, that's too big. That's probably better. A little smaller. Ooh, I gotta fix that. Okay, that's gross. Where were we? Yeah. So you'll see, I mean, I is 10, right? So even though I hit the first branch, I don't go on, right? Because you would always see the else statements in here too, right? Yeah, it's a great question. So if you guys have used switch statements in other languages, there's this, like, hey, how you doing? I've seen that. I'm only commenting on this because I've seen this like 60 or 70 times now. Like, there's some ad that keeps coming up when I go to websites. It's like some test, some question from a programming test using. Have you guys seen this before? Has anyone seen this? What's that? Is it called triple byte? Yeah, it's this like test using a switch statement in Python or something, and I keep thinking like, I don't care what the answer is, right? It's just stupid, right? Like, why should I have to think about stuff like this? So I think, so in some languages, like switch statements will fall through, right? And you can hit multiple cases. And there's like 2 or 3 places where that's useful, and 2 or 3 million times that's caused problems for people, right? So I think here the idea is the default is to break out things, right? So you get one thing out of your when. Great question. Any other questions about stuff regarding this? Yeah. That's a good question. Let's see here. So, yeah, I tried that when I was, so to be honest, I don't know the answers to all these questions, right? So we're going to just sort of figure out together. So the question here was, is there any way to do, you kind of want something like this? Yeah. This doesn't work. This is going to blow up, right? I don't, so now if you do it this way, you can, right? So so the idea is that when I think this sort of thing is more eliminating. This gives you the ability to do sort of equality and range testing, right? One of the places, and again, we'll come back and we'll talk more about the type system and generics and polymorphism later, but one of the places where this type of statement is a lot more useful is when you're doing actual type testing, right? You have some type of reference to some type of object. You're not exactly sure what it is, and you want to kind of do something based on that. There's a form of this statement that allows you to say, if this is a string, do one thing. If it's a number, do something else, right? Right. That's kind of, I think, what this statement is really more designed for, right? So yeah, if you want to use this alternative format down here, this will do what you want, right? It is a little less elegant. You have the things in there. Great questions. Other questions? So, I mean, one thing I want to point out, just, since we're all here together, is that this, I'm doing this, partly for me. I enjoy talking about Kotlin, but, mainly for you guys. So if you guys have things that you want to talk about, if I'm moving too fast, if I'm moving too slow, I can't really help you because I'm developing the materials as fast as I can. But if I'm moving too fast, I'll be happy to slow down. All right, so today we're going to talk about, last time we talked about loops. I just wanted to point out this last little thing down here, which we didn't get to last time. So, we looked at ways to essentially kind of loop over, looping using numeric constraints, right? This example right here where I'm going through a range of values. The dot syntax is inclusive. I pointed this out. I don't know if we actually looked at this on an example, but that in Kotlin, this produces, so this operator actually produces an object. It's replaced by an actual object of the type, in this case, int range. And so I can use that. I can save that into a variable. So go down here. We could say something like, val range is equal to, and then pass that into this function, which is expecting a range, and it'll do the right thing, right? There is, and again, if you have, like, if it sort of brings you a lot of joy to write like various types of strange for loops that start in weird places and end in weird places and like have weird step sizes, you can do that, right? And this is kind of the syntax for it. There's more where this came from, but this is, so 8 down to 1, it can change the step size. It's like, is this stuff, and these produce something that's a little bit different. So this is an int progression. That's a different type of object. But again, these kind of do what you would expect. All right, so but let's go on, and this is sort of boring stuff. Okay, so if you were here for the first class, one of the things that I really like, and I wanted to introduce right away, because we're actually going to use this. It's actually difficult to kind of go on very much farther and talk about some of Kotlin's nice support for things like collections and null checking and things like that without talking about object and object references, right? In order to do that, we actually want to be able to start building and using some simple objects. And happily in Kotlin, this is really, really straightforward to do. All right, so Kotlin has support for something called data classes. This is a specific kind of object in Kotlin, and we're going to talk about what you get when you mark a class as being a data class. There are some limitations as well, but we're not really going to get into the limitations today because the limitations require understanding what a class can do in Kotlin, and we're not going to talk about that yet. But we are going to talk about data classes, and then we're going to use them for the next couple of lessons to look at some things. So, Kotlin inherits Java's object models, as we mentioned last time. So everything, everything. And in Kotlin, it's even more complete because even these things that look like primitive types and I can assign with literals like, ints that in Java might be primitive types, these strange sort of exceptions from Java's type system are actually objects in Kotlin. But, one of my favorite things to make fun of Java for is how much, and I have to give Ben credit for coming up with this word, how much ceremony there is in creating like even a very simple object in Java that I just want to be able to use to store like 2 fields. Okay, I want a person, and like I do this in 125. In fact, we actually do a simpler version of it. So here's my person class in Java. This class works. It stores 2 fields. It is 32 lines of code to store 2 fields and to provide like basic stuff, like a setter and a getter. Like I would like to have that as part of my class, please. It's really not that. Shouldn't really be that hard, right? This is, now again, like there are probably sort of libraries that have annotations that you can use to do this, and your IDE will generate this code for you, but it's still like an awful lot of code, awful lot of syntax just to get like one class that allows me to store 2 fields, right? And then imagine if I want to make a change to my data model later or whatever, going back and cleaning all this stuff up. It's a real nightmare. Right? This is not something that Java is good at. Okay, so Python's a little better at this. I was actually really happy to discover when I was writing this that Python has data classes now, as of Python 3.7. Does anyone know this stuff about Python? How many people here use Python? Okay, so if you're a Python user, let me give you a hint. You should figure this stuff out because like these are good features. Right? Python is evolving. I'm really happy to see this. This is not particularly new. Sorry, this is mid-2018. This has been around for a couple years. So now, apparently, instead of writing this in Python, which is what you kind of had to do before, you can write this. Okay? You use this data class annotation. You tell it the fields you want, and look at these. Wow, Python with the type hints. That's new too. Kind of cool. I do still have to write my underscore underscore stir underscore underscore method, right? Beautifully named, to give me a string representation of this object. But this is nice. Yeah, this is not Python's showing some evolution here, which is cool. All right, and again, I've already bragged about this, but this is how you do this in Kotlin, right? It could be one line. I expanded it to 4, just to try to be fair. And this is an example of declaring a data class in Kotlin, right? So you'll see the syntax. I have class, the name of my class, and I stick this data keyword in front of it. And again, we're going to talk about what you get when you create a data class in Python, what comes along with that. Here I'm defining 2 properties that are part of my data class. The first is a name, and this looks a little bit like variable declaration syntax in Kotlin, except I have to specify the type here. Kotlin will not do type inference inside of a constructor, and this is essentially a constructor. That's what this is. So here I'm saying that each person is going to have 2 fields. I'm going to have a name. The name is a string. I'm going to have an age. The age is an int. Both of these can be modified. So these are both var. Var and val mean the same thing inside a data class constructor as they mean when I apply them to a variable declaration, so whether or not this is modifiable or not. Now I've got a person object, and I can do stuff with my person. One of the things I can do is I can print them, and I get this nice representation, right? I got that for free. I didn't write this, right? This just came along with it, and again, there's a couple of other things that come along. All right, so I think I've said some of this already. When you set up your data class, what you need to know about it is, what are the pieces of data that you want, that you need to model whatever thing in the world you're modeling. And you can do that, and what do you get? So let's look at some of the things that you get. So you can mark each property of your class as either mutable or immutable. The immutable properties, the unchangeable properties, have to be set in the constructor. Once they're set, they're fixed, they can't be changed. So here, for example, I've marked the name is immutable in my new person. It's a little bit different than the one that you just a minute ago. And so if I try to change it afterwards, I can use the same property access syntax that I use. Well, actually, I don't even use this in Java. We'll come back and talk about this in a sec. So here I can't change the name because it's been marked as a val, so it's immutable. I also can define default arguments in my data class constructor. So we've seen that over here, right? I can say age is an int, and then if it's not specified, it's 0. Okay, and so I can use 2 forms of this. In fact, I have more at my disposal that we'll see in a sec. So I can either set both fields, or I can set just the required field, right? If I wanted to set a default value for the name, I could do that as well. So, again, if you've used Python and if you've used JavaScript and stuff like that, you've gotten really used to this type of property access syntax in your programming, and this is a particularly nice way of doing things. What would this look like in Java? What would I have to do here? Typically, if I'm writing sort of idiomatic Java following modern coding conventions, yeah. Yeah, this would be a method call, right? So this would be like person.setName is equal, and then I would pass that in. And it turns out that I can do this in Kotlin. I think. Let's try it. Let's see if I'm not lying. Well, sorry. I need to mark the name as variable first. Oh, yeah, okay. It doesn't like that. Internally, so if you think about what Kotlin is doing when it compiles its code, internally what's happening here is that I am making a method call, right? And we'll see when we come back and talk more about how we can design complete classes in Kotlin that you have, just like you do in Java, you have complete control over how the property access works, both when things are retrieved and when they're set. So there is a function that's being run here. And happily, it doesn't look like a function call. It looks like an assignment, but there is a function that's being run that's being passed the string challenge and can do something, right? With the data class, by default, it does the thing that you would expect it to do, right, which is it changes the value. Okay, let's set this back to val. right? Okay, so now I can't do this. I'm going to get rid of that. And I've got, again, some nice, I can modify fields that are marked as being modifiable, and I've got my nice print method. So this is good. This is actually quite nice. So when I'm setting up my instances of data classes, I can use both positional arguments, which are, so just to be clear what we're talking about, a positional argument is, examples of that are on lines 3 and 4, where what Kotlin is doing is it's determining which argument is which by the position of the argument in the list. Right? This is the default, and this is something you've probably all gotten used to from Java and stuff like that. I can also, however, use named arguments, right? And this can be very, very convenient. And this is really the only way, for example, if here both the name and the age have default values, but there's no way to call the constructor with just the age without using a named argument, right? So if I try to do this, right, let's say I try to call a constructor, then it's going to be angry, right? Because the problem is that it thinks that this is an argument for the name, right? So here, if I really want to get the default name argument, why is it angry with me? I think there's a mismatched. There it is. Yeah. Okay. There we go. Yeah. Okay. So you see all this, and they can be in either order, right? And again, if you've used Python, this is something that you've probably liked about it, right? Because a Python function. And this is really just a function call, and we can use the same approach in functions. But the same thing here in my constructors. Actually, I'm not sure that's true. Somebody should make sure that that's true when we talk about functions on Wednesday. The constructor can accept these parameters, right? And this is a nice, sort of elegant thing to be able to do. Any questions about this so far? Right? I think this is, yeah, David.
This isn't necessarily about data classes, but if we want to write Kotlin code, does it need to be inside of a function, or can we kind of use Kotlin?
Okay. Yeah, great question. I think we talked about this before, but I'm not sure. So, in general, if we're talking about, so Kotlin actually distinguishes between two types of files. There's a Kotlin file, and then there's something called a Kotlin script. Now, a Kotlin file, everything has to be inside a function, unless I'm doing certain things like setting up top-level variables and stuff like that, right? So, for example, I can declare variables outside. This is a good question. Yeah, I can declare variables outside of my function. So I could say val whatever is equal to 10. That's fine, right? And then inside this function, I can access that if I can get to the bottom here. Come on. Oh, come on. Just get rid of this. This is available to my main method, right? If I start trying to do stuff with this out here, like let's try to modify it, then I can't do that, right? So I can declare variables, I can declare functions. Essentially, my Kotlin code can contain declarations, right? It can't contain any.
So are the declarations, are they inside of a class that we can?
Nope. Oh, okay. So the question is this the equivalent of what we're doing in 125 right now, where we're kind of templating these into side classes? The answer is no. This is valid Kotlin code, right? Kotlin does not require that you have everything inside a class. You can write top-level functions, and in many cases, this is a pretty useful thing to be able to do, right? Now, internally, right, so this is Java still, this is bytecode. When Kotlin compiles your code into bytecode, it does actually end up putting these things into classes, right? So how do you call main here? What happens is, if this is in a file called main.kt, Kotlin creates a class called main.kt, and then main is part of that class, right? So that's how you would have to call, right? But Kotlin does provide more flexibility in terms of how you organize your code. Kotlin scripts, on the other hand, can contain loose code. So Kotlin scripts can contain, modifications to variables, very similar to what you might be used to with Python or JavaScript or whatever. I could just write code in my Python file from top to bottom, right? And it just will execute that, right? These playground examples behave like a Kotlin class, right? I'd like to, at some point, figure out how to get support into our playground for running Kotlin scripts, but we haven't done that yet. Yeah. One of the reasons why Kotlin scripts are so useful is they get used to do things like configure Gradle and stuff like that. So there's tools now that will take a Kotlin script as a configuration file, right? And this actually, I think by the end of the semester, we'll look at this a little bit together because this will be fun. One of the things that Kotlin allows you to do, which is really cool, is it basically allows you to create these little, its syntax supports the use of Kotlin is to build what are called domain-specific languages, right? So the configuration for Gradle, for example, essentially relies on a domain-specific language that allows me to both configure, but configure in a programmatic way, right? Kotlin supports this. I know what I said just probably doesn't make any sense, but we'll get there. We'll talk about it later, and we'll show you. It's actually quite slick. All right, good questions. Any other questions before we move on? Yeah. Can I inherit from a data class? Let's try it. All right, so let's try data, and I'll show you the syntax for this. Name string. Well, actually, sorry, I don't think so. String age int val ID. I'll give you guys an ID, and then we'll say person name age. Something is wrong with this, and I'm not sure what it is, right? There are limitations of data classes associated with how they fit into the the hierarchy, right? I think the answer is yes, and I just didn't do that correctly, right? But yeah, but we'll come back and talk about this when we talk about the full class model, right? Yeah, it's a good question. There's another hand up over there. Yeah. Right. So the question is, well, again, see, let's see if we do or not. Yeah, we do. This is one place where Kotlin just will not do type inference for you. It's a great question. Like, could it? Maybe. Yeah. You can't inherit from data classes. There we go. I'm glad Max is here to set me straight. Yeah. So data classes cannot be inherited. Now I feel smarter. Yeah, the Kotlin will not allow you to, it will not do type inference here. Could it? Maybe. There's probably a reason not to do this. This is one of those places where it's sort of like a method, I feel like, where you're establishing a contract. And particularly for someone reading your code, I think this is actually a little clearer, right? This gives me a really nice sense of what I expect the parameters to be. Other questions? These are good. All right. So now let's see what we get out of this data class. Because, again, I don't have to do this. So I don't want you to think the data is somehow... So there's these... So one of the things that Kotlin is good at, if some of you have written like modern Java or modern Python, or really any... Has anyone worked with like annotation systems before in Java or Python? So yeah, so there are these ways to like put little annotations on things, and then all this weird magic happens, right? And Kotlin tries to avoid that. Kotlin does allow you to use annotations, and they're useful in certain places, but I don't want you to think that this like data keyword is somehow something that's totally causing this class to behave in this completely weird way. It's like, oh, well, it's just like Java, and you have to write 30 lines, except if you put data on it, that like it's a shortcut, right? So this is also valid, Kotlin code. And this, I'm going to, we're going to print this. Now, you might have noticed something different about this already, right? So you might have noticed one of the things that we get when we add data, right? So, but otherwise, it works exactly the same. So data class, I see a nice printed thing. Normal class, I don't, right? So one of the things that we get out of the data definition is a nice toString method, right? That just uses the names of the fields and their values, prints them in a comma separated way. That's nice. One fewer line of code I had to write and maintain, right? Another thing, okay? So actually, let's go back and we'll use this example a few times just to point this out, right? So you know, let's create another person. Okay, and then we'll say okay. These two people have the same name and age. Seems like that's a reasonable definition of equality. They're not equal, right? Why aren't they equal? If you guys remember back from Java, if I don't provide an equals method in Java, what do I fall back to? Reference equality. So literally, are they in the same location in memory? Answer is no, right? And so I get false here. Right? If I stick a data class annotation on here, then I get these very reasonable notions of equality that are based on the fields that I've defined. What else are you noticing about this example? It's on the slide. Another piece of happiness here. What other bit of syntactic frustration have we cleared up from Java here? I mean, normally this is, if I was showing you this in Java, I'd be expecting you guys to see a bug, right? What am I doing? What would I be doing wrong here in Java? There's something that's just not correct. Yeah. Oh, there's no new keyword? Okay, so that's a great thing to point out. There is no new keyword because what were they for, right? So we got rid of that. That's also true. What else? Yeah. Yeah, I'm using double equal to compare objects. That's not supposed to be something I'm supposed to do. This is supposed to compare object references. This is one of the places where Kotlin was like, whoever wants to compare object references? It's almost always the wrong thing to do, right? And so why don't we just have that call dot equals, which is essentially what it does behind the scenes, right? So in Kotlin, we do not use dot equals. We use double equals, and we expect it to work properly based on the definition of equality that we've established for that particular class, right? When I create a data class, I get a definition of equality that's based on the equality of the fields that my data class provides, right? Again, I take this off, right? So I move data, I lose that nice definition of equality, which is useful. And I need to put class back too. Okay, good. I get a copy constructor, right? That's pretty useful, actually. So let's say I want to make a copy of a particular data class. You know, I can write this. Again, this isn't on those pieces of code in Java that the IDE can very easily generate for you. But, you know, why? Right? Why not just have this work, right? So if I want a, you know, new copy of myself, I call data class.copy, and what I get back is something that has the same fields that's equal, right? That's what we would want. It's also just worth pointing out here that the copy constructor allows me to override fields on the way to creating my new person object, and I can also override immutable fields. So this is kind of happening during object construction, not afterwards. It's not like I create the object and then I'm modifying the fields, because if I was doing that, this wouldn't work, right? Name here is immutable. It's marked as a val. So, but here what I'm doing is I'm copying Jeffrey, except I'm modifying just one of the fields. I can modify all the fields if I want to, but I can modify as many as I want in the copy method. Right. All right. So again, there are some limitations to data classes, right? And I have a link to a page that talks a little bit about them. But I just want to make sure one thing. To point out one thing. Again, we're introducing data classes now so that we can use them when we start talking about collections and working with map, filter, and reduce. And you know, if I was teaching an intro class, this is exactly what I would do, right? Because they're useful, right? And we can actually do a fair amount with data just using these without having to think about all the complexities of the object model. We'll get to that. But I don't want to make you think that data classes can't, for example, have methods. They can, right? So here's an example of a data class that also includes a method. That method increases the age by 1, right? So data classes, there was an earlier idea of something sort of like a proto-object or a proto-class that was known as a record, right? That is a previous idea in computer science. Records are like objects that can't do anything. They don't have any methods. All they do is sort of bind together different pieces of data, right? Data classes are not records. If you don't add any methods to them, they're sort of like records, but you can add methods to them if you need them to do useful stuff. Yeah. Mm-hmm. I don't know. Max? Can I compare references in Kotlin? Triple equals. Oh, look at that. We're going to 3 equal signs. Let's try it. Gosh. Oh, cool. It works. Yeah. There you go. Oh no, actually, that should say false anyway. Let's try a place where it should say true. So up here, okay. So this should say false. Yeah, there we go. Look at that. So, and again, like I don't want to put too fine a point on some of this stuff, but maybe one of you one day will be involved in designing a language, right? So here's my suggestion. Make double equals more useful than triple equals, right? And make and more useful than quadruple equals if you need to go to that level, right? Like, does anyone here write JavaScript? So in JavaScript, it's backwards. Like triple equals is what you want. Double equals is broken in ways that are weird, right? So linters will catch this for you, but it's like, wait. Yeah, anyway. Okay, cool. Thanks. Other questions? Yeah.
So are you able to change the definition of the double equal equality? So, for example, if you wanted 2 people to be equal just based on their name, but not based on their age.
Yep, we can do that. Let's try it. Equals. What's the signature of equals? Should be just other? Max, help. Is that right? Let's just try this. Clearly not. Why can't I just override equals?
You might need to override operator equals.
Ah, there it goes. No. Oh, there we go. No, we're getting closer though. I think it has to be any, right? I think it has to be nullable. No. It says return type of equals is not a subtype of the return type of the over another. Oh, sorry, it has to return a Boolean. We're talking about functions on Wednesday, guys. Please. All right, there we go. And at which point I will understand how they work perfectly. Yeah, there you go. Look at we did it. Google that shit. So yeah, and so here you can do whatever you want, right? Now actually let's do some let's do this. Let's do if other as person. We'll do return other dot name. Name is equal to other dot name. Else return false. I think this works. Return. Was it is? Ah, there we go. So actually, I know we're getting ahead of ourselves a little bit, but I want to show you something about this because this is cool, okay? What's the type of other when I start executing line 3? Any question mark. So this is essentially equivalent to Java's object. I have no idea what this is, okay? And remember, when I override equals in Java, I have to handle the case where the thing that's passed in is a type that isn't even the right type, okay? So in Java, I have a way to do this. I use the instance of method, right? But what do I have to do after instance of in Java? I have to downcast it, okay? Here I don't. So Kotlin is clever enough where it says if other is person, that does two things for me. Right? First of all, it checks the type of other. But when I get inside the if statement on line 4, other is now downcast for me. Right? So this is really nice, right? You know, no more like I don't need another variable. I don't have to do a downcast, which always makes me feel queasy. It just works. This is pretty cool. Other questions? Other questions that lead to interesting digressions about things that we will get to in the future. Cool. Oh wait, actually, let me. I don't know how that works though. I'm not going to talk about that. All right. Okay. Let's go on. Next lesson, collections. All right, here we go. So, Kotlin supports lists and maps. These are, as I sometimes refer to, the two data structures you meet in heaven. They are probably the most useful data structures you will ever learn. And, you know, so what's a list? A list is an ordered data structure. It's modifiable most of the time. It puts things in order, okay? And again, thanks to Kotlin's type inference, I can start writing code that looks a lot more Python-esque than Java-esque, right? This is the valid list declaration initialization in Kotlin. The list of function takes, you know, the arguments that I wanted to put in my list, and because I'm passing those explicitly, it can determine what the type of the list is, okay? This is the easiest way to create a list, is to use the list of operator if you have some items that you want to put into it. And we're going to see in a minute that if you use list of, you had better have some items, because it's not that useful otherwise, for a reason that I'll show you in a minute. So I can create lists of whatever I want. And I can print them, and the print method for lists is nice. It's comma separated. Okay. So, like lists in Java and Python, lists know how long they are. And you can iterate through them in a variety of different ways, right? Probably if you're determined to use a for loop, and I'm hoping many of you will be less determined to do that by the end of the semester, but you can use the sort of for in loop as shown on line 4, right? That works beautifully. If you, for some reason, really like indices or need one, you can use this as well. There's probably a better way to do that, actually. Harsh is going to figure it out for me and tell me. Is there like a enumerate equivalent in Kotlin that will give me like pairs of? There probably is. I'll look it up. I'll figure that out. There's probably a better way to do this. But anyway, in this case, I have the index and I have a way, and I can use it, right? So square bracketing works like you would expect. It works like arrays, right? So again, remember back to Java, if you must, and how do I can use array lists in Java, but how do I have to get and set the elements programmatically, right? So it's, you know, array list.get index. Here, I can just use square bracket notation, which is much, much more elegant, clean, right? Finally, you know, again, be careful with these index for loops. This seems like a really natural way to write this iteration, and it's wrong, because it will walk off the end of the list. Remember, ... is inclusive, so this will go all the way up to list_size, at which point I have a problem. Hold on a sec. Kotlin. I just want to see if Kotlin has a list enumerate. Yeah, okay. You can do it using more of a functional approach. We'll get there. Okay. Now, you start working with, so I've done this several times actually, right? Where particularly in the IDE, you start working with your list, you create a list, you're feeling good, and then you start trying to do some stuff with it, and you're like, particularly if you start trying to do things that would modify the size, right? And not only will add fail, but like your list won't have an add operation, right? You'll be like dot, and you'll start typing A, and be like, why isn't it auto-completing, right? Lists in Kotlin are immutable by default. So list of gives you an immutable list. You cannot modify its elements. You cannot change the number of elements. This is an interesting design choice, and one that I kind of like, right? So if I try to run this, so actually, again, what it's complaining about on line 5 is there is no set method, right? There's no set method on an immutable list in Kotlin because I don't need it. I can't change the elements. Same thing down here. There's unresolved reference add. There's no no add method on a Kotlin immutable list, right? If you want a mutable list, use mutable list of. Not that different. Now these things work the way that you would expect. I have, just like the lists that we know and love from Python and JavaScript, I can push things to the front, I can pop them off the back, I can insert them where I want, I can use bracket notation to change the values, whatever, okay? Now again, I think this is an interesting design choice, right, in the sense that, Kotlin could have said, let's have lists be mutable by default. List of could have given you a mutable list, and then you could have had something called immutable list of. But Kotlin is really encouraging us not to mutate data, and this is good practice for a variety of reasons. At the end of today, maybe going on Wednesday, we'll talk about all the really beautiful support Kotlin has for working with lists in ways that are inspired by more functional programming approaches that don't require that you modify their values. You don't need to modify a list in order to transform it. In many cases, it's the wrong thing to do. Okay, so good. The other thing just to keep in mind is that a lot of times if you have some sort of ordered data structure in Kotlin, you can get a list out of it somehow, right? ToList is supported by a bunch of different things. So here's a place where I'm taking a range, I'm converting that to a list, and then I'm printing it by calling this nice join to string method, which we'll talk about later. All right. Okay, so this was by far the most fun example that I wrote up for this for today's lesson. So hopefully this will make things crystal clear. List mutability and variable mutability, or collection mutability and variable mutability, are not the same thing, and they're both possible and interchangeable, right? So val and var are used to determine whether or not I can change the thing that a variable refers to. Mutable and sort of mutable maps and immutable maps and lists determine whether or not I can change the elements inside the collection. Well, those are two different things. So first example on line 2, I have an immutable variable and an immutable list. So I can't even modify the value of the variable on line 4. I can't set it to a new immutable list because it's marked as a val. And I also can't change its values. The second example, the variable is mutable, but the list is not. So I can run line 9 because list 1 has been marked as a var, but I can't modify the list because I've created it using list of. Line 12, now I've got an immutable variable, mutable list. So I can't run line 14 because I can't change the value of the variable, but I can run line 15 because I can modify the list. The list was created using mutable list of. Last example is everything's mutable. So I can both modify the values inside the collection and change the collection that the variable refers to. All right, so let's go through here. I encourage you as an exercise to the reader to try to get this to work without just reading my annotations, which is the easiest way to do it. There you go. Putting any of these back is going to cause things to blow up, right, in a couple different ways. Questions about this? This is, just a little, this subtle on some level. It's something you'll get used to, right? Val and var, are property of the variable and not allow me to reassign it to a different object of any kind, right? The list and mutable list and map and mutable map, which we're about to see, this determines protections applied to the collection of elements, right? Okay, good. I won't delve too much into the comparison between Python and Java. I need to work on this more. Although, I mean, to be honest, it's like, I started talking about arrays in 125 today. This is why I don't talk about array lists in 125 earlier, right? Because this is just like, I don't actually think that there's a cleaner way to do this. I tried using the diamond operator over here, and it doesn't like it because it's on the left side. And like, this is just, like, don't know. It makes me unhappy. Python is nicer. This is why people like to start with Python. There it is. So. Okay, lists, check. Maps, check. Lists, the most basic ordered data structure. Maps, the most basic associative data structure. So let's put items in order. Maps establish a one-to-one relationship between keys and values. I shouldn't say one-to-one. It can be one to many to one. Many to many. I can create maps, same way I create lists. The syntax is a little bit different because I need to provide both the key and the value. So this is kind of nice. This creates a mapping Challen to Jeffrey Challen, age deep to harsh deep. Is that your net ID? Okay, good. I figured there was a 2, but I don't know how many, maybe a 3 or 4. And then I can retrieve items from this map by using the keys that I used, right? So again, using mixtures of maps and lists, you can pretty much do anything you want. With data, maps support bracket notation. So you can see here that rather than calling get whatever, I'm allowed to use anything that's the same type as the keys in the map in order to retrieve things from it. Right? In this case, the keys in my map are strings. The values are also strings. But I can create maps in Kotlin, just like in Java, that map between any two types of objects. Just like I can create lists that contain any type of object. I have the same distinctions between mutable and immutable that I had with lists. So I'm not going to dwell on it here. I have mutable maps. I have immutable maps. A mutable map, I cannot either modify an existing mapping or add a new mapping. A mutable map, I can do both. I think I pointed this out above and just forgot to mention it. Both lists and maps, if you have a mutable list and you want an immutable list, you can call to list. If you have a mutable map, if you have an immutable map and you want a mutable map, you can call to mutable map. That does not change. So that's actually a great point, right? I want to make sure that this makes sense. Kotlin is encouraging us to transform rather than mutate our data. So this does not change name by ID. It returns a new map that is mutable, right? So if I want this to work, I've got to comment out these things that are broken. Oh, right, of course, yeah. And because, again, if you've used Python, these are Python dictionaries, right? But I get type safety. So this can't work, right? Because when I set up the map, up here, actually the original map, I set it up mapping strings to strings. And so I can't use an int as a key. Get rid of this. Now it should run. Great. Cool. There's a couple of different approaches for iterating through maps. Obviously, map iteration is a little bit different than list iteration in the sense that maps don't provide an order. But there's many times where I actually want to go through every one of the mappings that's stored in the map, right, to do something with them, right? A couple different ways to do that. Every map has both a dot keys and a dot values property that produce a list of all the keys in the map. Oh, I don't think we've seen this before either. I need to go back and put this in the preliminary section, but we already got through there. String interpolation in Kotlin. Again, one of the other things that makes me very happy, right? So this is valid Kotlin, okay? What is this doing? This is building a string. How does it work? $ variable that inserts the value of that variable at that point in the string. So now I'm getting the value of key, whatever is produced by calling toString. Over here, you'll see that I'm actually doing something a little bit cooler, which is that I can also use curly brackets, and then I can put any expression inside that I want, right? This is code. So now I could say this plus, let's see if it will let me do something like that. Yeah, there you go. Now I've ented us. So it's harsh deeped. Kind of like that actually. It's like it's a hard P. So I can basically put anything, any sort of valid snippet of valid Kotlin expression inside that, right? And so this is something that we're going to start using. I should have covered this earlier, but there it is. Any questions about that? This is a very, very nice feature of the language. Yeah, Dave.
Side question.
Mhm.
Are maps knowable? So can you declare a variable that's supposed to store a map, but it can also store null?
So any time, any variable in Kotlin, I can allow it to be nullable, right? I'll show you how to do this in a sec, right? Do I want to do that? No. Generally, we try to avoid that, right? But you can. Now, there's a difference between a nullable map and a map that can store null, right? And I can have both, right? And let me get down the page a little bit, and we'll come back to this, right? Different way of iterating through a map. It's more Kotliniomatic, which is a word I made up, and I'm going to start using a lot. This for in syntax, and you'll see something else that Kotlin does, which we'll talk about more at some point, which is destructuring. So this gives us two values. So essentially, I'm pulling things out of this gives me a way to walk through all the mappings in the map, where the key and the value are saved into these variables, and then I can just print them using the same type of string interpolation that I used before. And again, I'm using loops for these examples because there's sort of a chicken and the egg problem. I really want to, and it looks like we'll be doing this on Wednesday, start talking about how to use more functional approaches to go through data in Kotlin. But we need some collections to work with first, right? So for now, we're using loops, but for loops will be banished from these lessons pretty soon, because they're just not the right way to do things in Kotlin. Okay. So up until this point, and again, I just want to point this out. This is a really nice feature of the language. We have not seen a type attached to any of the lists that we've created, because we've been using these list creators, list of, and mutable list of, and as long as I pass things to them, they can do a great job of inferring what the right type for my list or my map is, right? So again, I mean, the map of operator looks at the values that I provided and the keys that I provided and says, okay, this is a map from ints to strings. That's straightforward. Same thing up there. This is a list of ints. But what about if I want to create an empty list? And again, just remember, if you call list of and don't give it any elements, you are in trouble, right? You have an empty list that you can never add or remove anything from. So it's not going to be very interesting, right? So the only time you really ever want to use this form is if you have a mutable list, right? Because aren't you going to want to put something in there? If not, why are you creating it in the first place, right? Now, if I don't provide any elements, then there's no way for the type inference to succeed, right? On second. So on line 3, there is no way for Kotlin to know what type that list should have. If I want to tell it, I can use this form of the mutable list of operator, right? So mutable list of will take a type parameter. How many people remember their generics from Java? Right, this is Kotlin's generics, right? Works very similarly. So all these collections are generic collections in Kotlin, right? They can store any items, a list of any items, or mappings between any types of items. And I can provide type parameters to them in the same way that I would do for an array list. So now what I'm getting is an empty list of ints, because I've told Kotlin that that's what I want. And I have to do that, because if I don't, there's no way for it to know, right? So now we comment out this failing declaration. And also, of course, if I try to put something in the list that's not an int, it's gonna yell at me. Okay. Maps work similarly, except obviously for a map, I need to provide both a key and a value. So this is a map from ints to strings. Oh, sorry. There's actually two ways to do this. I'm showing you both. So I can provide the type parameters to the map creation function. So this says, create me an empty map, mapping from int to string. I can also type the variable, right? And we saw a little bit about how to do this by putting a type past the colon. This is a little bit confusing, so let's just pause here because there's a difference in case here. That's the only difference, right? So capital mutable map is a type. So I'm saying my variable fourth should be a mutable map from int to string. And then I call the map creator function. Now at this point, the map creator function basically looks to the left and says, okay, well, I know what kind of map you want, right? You already provided the parameters. So that's one way to do it, right, where the type information is moving from the left to the right. On the previous line, the type information is moving from the right to the left. So mutable map of is getting called, and it's told to create a map from int to string, and then Kotlin's type inference then tells it that third has type mutable map int to string. So these are equivalent. You don't ever really need to use both of them, right? I would argue that the one that third is a little bit cleaner, except it doesn't handle the case that David brought up before. So what if I want my map to be null? Again, I do not suggest that you do this, okay? Because then you'll do something dumb with it. So how do I get a nullable type? In Kotlin, I put a question mark after it. That goes for maps too. I know there's some extra syntax here because I have to give it the type parameters, but now I should be able to do this. Oh, sorry, it's mad about this guy. There you go, right? So now what's happening here, I'm saying I want a variable called fourth. That variable is going to be a mutable map from int to string. It's also nullable, so it can take on a null value, right? It's also, actually, this is a really dumb line of code, right? Because I've created a val, so I can never change it, right? So now I've got a null map. What am I going to do with that? I don't know. Hopefully David has a good idea. I don't know. But if it made this a var, it would make more sense, right? But anyway, but this will work, right? So there's no way to accomplish the same thing here, right? So if I provide the, I gotta leave this, otherwise it's gonna get mad. If I provide it, once I call mutable map of, I'm getting a map, right? I can't get null from that function. And so if I really want a nullable map, I have to use this form, right? Even if, I make it, so you might have a case where the map is null sometimes. So I can do something like this, mutable map of, and that'll work fine, right? So now my variable can be nullable, but it's being assigned an initial value of an empty mutable map. What about if I want a mutable map that I can store null in? I can do this. That works. Okay, so now third is a mutable map from integers to strings, except that it can store null. And so I have actually never tried this, but let's see. Oh, there it goes. Look at that. So for some reason, if you need to map null, you got that. Yeah. Probably null is more useful, typically, I would argue, maybe, if it's ever useful, on the right side. Oh, now it's angry. Why is it upset with me? Oh, I need to put something in here. There we go. So now I can do something like this if I want to store null values in my map. Okay. So someone, we ran into this last time, and someone pointed this out. So even when Kotlin's type inference works, sometimes it can be helpful to specify the types of your map so that you can help yourself catch mistakes, right? So, as a broader point, if you start to look at some of the languages that are adopting sort of gradual typing approaches, right? Whether it's TypeScript for JavaScript or whatever is happening in Python in the typing space, that types exist to help you catch errors. So even if you're using a language that doesn't require that it be able to, understand what the type of every piece of data you use is, you adding that information can be helpful, right, for yourself. It helps you avoid mistakes. So again, here's an example. Now this one's kind of dumb, right? But this will work, right? Well, it won't work. The map creation will work, right? But I'm getting this weird error down here, okay? What happened here? Can someone explain to me why this piece of code didn't work? Note that the map creation is fine. This error occurred in my loop. I was going through the values in the map. Yeah. Yeah, so what happened here? The map got created, right? And this is, well, you may not know what happened, but let's just try to puzzle through what happened. So it seems like mutable map created us a map, which was nice. But what was the type of the value? I mean, so mutable map goes through the values, okay? And in this case, it says, okay, well, the first value is an int. The second one is a string. I actually don't know. Max, you Google this shit? I'm assuming that what it does is it finds the common ancestor of the two types, of all the types, but I don't know. Maybe it just defaults to any, right? That would also make sense. So if there are different types in the value, it's also possible that mutable map just gives up and says, I'll just use any, right? And so now the problem is my loop, I get down to line 4, and I've got a value. Now the value may be of type int, but I can't add 4 to it. Even if I deleted 2 from my map, which I can do. Let's just take that key out, right? So let's do broken.remove. Is that right? Yeah, it still doesn't work, right? So even after I take out the mapping that has a string, it doesn't matter because the type of the map is any. The values in the map are now any values, and I can't take an any and add 4 to it. Kotlin won't do math on any's. Okay. Now, if I was a smarter programmer and I told myself, okay, I'm going to make sure that, I specify the type here that I want something that's int to int. Now I've got a compile time problem, right? Where I can make sure, okay, oops, I meant this to be that or whatever it was. Okay. So again, when I stick type declarations into the map, that can help me with things like this. Questions? David.
Can you downcast in the loop to make it work? So
Yeah. Yeah, so that's actually an interesting idea. So let's do this. Let's use that combination type check and downcast operator. So let's say if value is int, then I will print the value of it, plus 4. And now I should be able to go back, remove this. Max, do we decide that it gives up and does any?
It definitely does in your example. I'm going to try something else.
Okay. So now what you'll see here is that even if I do it with the broken value, it's fine. Right? Yeah. And this is one place. So actually, we'll come back to a question that somebody asked earlier, right? This is another place where we can use our when syntax. So again, this is one of the core uses for this. Who asked that question before? It was you, and then I think also you had the question about, how do I use it? Does any? Yeah. So here's an example of when I have a map that has actually multiple types in it. I don't know what it is. I can write these when expressions, and I could handle any arbitrary number of cases, right? I could say is string, and I'll use string interpolation just to do something kind of silly. Yeah. Yeah, so this is one of the core uses of that construct. Okay, good. Any other questions? Yeah.
What happens to the map if you have them exclusion keys, let's say, what you call it? So if you, for example, in your mutable map of,
Mm-hmm.
you have 1 to 3, and 1, 2, 4.
Uh-huh. Oh, okay, that's interesting. So the question is, what if I put in duplicate mappings? Why is it angry with me about this? Oh, I know. Yeah, that's fine. It looks like it just overwrites it. Yeah, yeah. So actually, this was an interesting type error, though. Okay, let's go back and do this again. So and again, so I think it's fair. As I've been sort of working through some of these examples, it's been impressing me how strong Kotlin's type inference really is, right? So here's a great example. This is a compiler error. Why? This is kind of a weird error at first, right? I think like, why am I getting this error? Yeah. No, because remember, that's string interpolation. So I'm going to get the string plus 4, right? This worked when I had a string in my map. I just want to point that out, okay? So when I had a string in my map, this code was fine, no problem, right? As soon as I took that string out, now I have this problem. Why? Yeah.
Is it because it's looking at your map and it's seeing that you don't know any strings and it's
Yeah.
saying, this is dumb, why are you
Yeah, basically. So like Kotlin has been able to figure out, maybe once you guys start working in the IDE, you may find the Kotlin compiler sometimes to be a little slow. But, here's what you're getting for that. So it has been able to figure out that my map is from ints to ints, that my loop is extracting values from the map, that the value is the subject of this when statement, and that the when statement has an unnecessary branch, right? It is impossible to get here. Now, I think this error message could probably be better, right? But that's what's causing the problem, right? If I take this out, it's fine, right? So that's pretty cool, right? I mean, that's a level of understanding of your program that's pretty special, right? Pretty unusual for a compiler, right? Contrast that with the object O is equal to null print O dot hashcode, right? That's where Java C is, right? So this is, and again, error message you can quibble with, right? It might take you a little time to figure out what's going on, why you're getting this problem, but it is pretty cool that it's able to do that. All right, any other questions? I'll stick around for a few minutes if you guys have any questions. Okay, so last thing, I am going to put in the overrides. I promise. I'll do that today, actually. People keep emailing me about it, so then I keep thinking my algorithm is like wait for 24 hours after I get the last request. So I think that's passed now. I'll put them all in. You guys should be able to register today, Monday, Tuesday. I will bother you over email to do that because the 10th day I think is Wednesday, and I will increase the cap too for the class. Did you have a question about that, Daniel? No. The 10th day is next Wednesday. We started on Tuesday, right? So it's Tuesday. It's 10 business days. Yeah. 10 academic days. All right. I will see you guys on Wednesday.